Good day, guys. Then this is the last theorem of circle geometry, the theorem of tangent chord. Yes, tangent chord theorem. So it's so simple. They love to ask it in examination, so you need to grab it with understanding and proper analysis, guys. So yes, so you need to understand it critically, so because they may ask it in September or in December. I don't know, guys, but they will ask it. Maybe next year, I don't know when, but when you're doing grade 12 or when you're in grade 12 right now, it might be asked, or it may have been asked, maybe go term 1, I don't know. Yes, but let's just start. Theorem number 8, the last one. The angle, I'll just try to read it and explain it after. The angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternating segment. Okay, let me just explain what is happening here. The angle between a tangent. Where is the tangent here? Here's our tangent. ATB. You can have tangent AT or tangent TB, it's not a problem. But as long as this line is our tangent at point T, you can have tangent AT or tangent TB. Still not a problem. So angle between a tangent to a circle and a chord drawn from the point of contact. So we have an angle. This angle is between a tangent and a chord drawn from the point of contact. So from this diagram, you can see that we have an angle here. This is an angle. It's drawn from it is drawn between tangent TB. Yeah, I'll just explain this part also. This part it also plays a role in trying to prove this theorem, but it is not asked that much. But I'll just focus on the part that is asked too much in the examination, which is this part I'm trying to explain. So you have an angle here. Is drawn between a tangent TB and a chord. This is a chord, by the way. And not this one, as this, guys. So we have a, let me just explain. We have a chord drawn from the point of contact is equal to the angle in the alternate segment. So we have a chord. Basically, I said that I was nearly taking chord TQ because it was going to be wrong because it is not accommodating T2. Hence, I'm going to take tangent TC, this tangent, because it accommodates these two angles. Yes, chord TC, between an angle between a tangent and a chord. Angle T1 plus T2, basically. They're talking about that angle. But this angle is equal to the angle in the alternating segment. Angle on the other side of the circle. That is the meaning of alternating. On the other side of the circle. Alternating segment is on the other side of the circle. Basically, we check point T. Which angle does point T and point C meet or subtend? Which angle? Angle P, guys. This angle is made by chord TC. Basically, T2 plus T1 equal to angle P. I hope you clearly understand what is happening here. Sharp. Therefore, you need to prove that indeed this angle is equal to this angle, or those two angles that are equal. I hope I understand. So let us prove. Okay, this one is so simple. We are given that circle with center O. In the exam, they usually give you such information, but I'm just showing you how do we go about this question. They're giving circle center O, also giving tangents. They told you there's a tangent there, basically ATB, and chord. Obviously, the one we're trying to prove TC, chord TC. Then construction, or required to prove that they will just give you this information. Then when you just fill it up, but sometimes they will give you the whole information given, required to prove, and construction. You will just construct by yourself. You are required to prove that indeed T1 plus T2 is equal to angle P. T1 plus T2 equal angle P, guys, equal angle P. And then construction. What do you construct here? So we have point here. We'll show you in examination, but we have a point D here. So you need to construct diameter TD, basically. I hope you guys understand. I hope you clearly understand. TD, let's just join TD. Tangent there with freehand. So you're expected to construct such drawings in the examination. This is what you're expected to do in the examination, guys. We have joined, or we've constructed TD and join PD to form another angle of P, basically. So I've joined this angle here. Join PD to form P1 plus P2. P1 and P2 here. I hope guys understand. This is what you are expected to do in the examination. This is what you are expected to draw in the examination. Point center O. Then obviously you said that T1 plus T2 is equal to angle P2 right now. So you're right. You're just going to modify it P2. Okay? So let us go. Okay, construction. You have considered diameter. By the way, it's a diameter because it passes through the circle. Diameter TD, and it joins. And it's going to join PD. So this diameter TD is going to join PD to form P1 plus P2. I mean, or I could just say PD to join PD to form not P1 plus P2 but P1 and angle P2. I hope you guys understand. Then let us prove. Okay, proof. Now let us check. Remember, we must prove angles that are related to T1 plus T2 and angle P2. So we must just choose those angles that are related, basically. So from the diagram, you can see that P1 is equal to P2. I mean, P1 plus P2 is equal to 90 degrees. Reason? It's angles in semicircle. Remember, P1 plus P2 is equal to 90 degrees. Reason? Angle in a semicircle. That angle P is in a semicircle. Let us check, guys. What is a semicircle? A semicircle is an angle that is made or subtended by a diameter. Diameter TD, it makes angle P1 plus P2. Remember, guys. So it is 90 degree angle here. I don't know how can I draw it. You can just see it like this. Yes, 90 degree angle there. I hope you understand, guys. Then let us go again. Which I have just proven an angle that relates with angle P2. Then which angle does relate with T1 plus T2? As you can come back from the diagram here. Oh, by the way, we have formed T3 again here. This is the angle again here after you have drawn the diameter. As we have formed this angle P1, also you want to form T3 again, another angle T3. So what relates to T1 plus T2? We know that we have a tangent here, and this is our radius. Tangent perpendicular to radius, Theorem 6. Remember, we just proven it. If you didn't watch a video, go and watch the video to understand why do we say T1 plus T2 plus 30 equal to 90 degrees now. So T1 plus T2 plus T3 equal 90 degrees. Reason? Tangent perpendicular to radius. I hope you clearly understand, guys. Then logically, so guys, remember, by logic, therefore, this means that angle P1 plus P2 equal to T1 plus T2 plus T3, raising each equal 90 degrees. This is just logic, guys. I use logic because you can see that P1 plus P2 equals 90 degrees, T1 plus T2 plus T3 equals 90 degrees. By default, P1 plus P2 is going to be equal to T1 plus T2 plus T3 because of what? Each equals 90 degrees. I hope you understand where I'm going to. Now, here's an argument, but we still have but here. But guys, let's go back. Let us check something here. You can see that we have a butterfly angles here. Butterfly. We have butterfly angles there. Butterfly. This means that butterfly means okay, angles subtended by the same chord are equal, or angles in the same segment are equal. Basically, this angle here is equal to this angle, but D and C are not related because we want angles that are related to T1 plus T2 and P2. Yeah. So which angles are related to P1 and P2 and T1, T2, T3? Which angles are related? That will prove that will prove angles in the same segment. We can see that P1 and T3, P1 and T3, they are subtended by arc DC. Remember, DC makes P1, then DC makes T3. Angles subtended by the same arc. This arc DC it makes P1, DC again it makes T3. Let me just show you by color. Yeah. So this it makes this arc DC it makes P1, and arc DC it also makes T3. Therefore, these two angles are equal. I hope you can see clearly, guys. Okay, they are angles in the same segment. Yeah. Therefore, but here is an argument. But P1 is equals to T3. Reason, angles in the same segment. So if this is the case, therefore, remember, if P1 is equal to T3, this will mean that P2, the remaining angles inside P1 plus P2 and T1, T2, T3 are equal. If P1 is equal to T3, the remaining angles are equal between these all 5 angles that included T1, T2, T3, and P1 plus P2. We have already proven that P1 is equal to T3. This will mean that the remaining angles of both P and T are equal. Which angles are left? P2 and T1 plus T2 are equal, basically. So therefore, P2 is equals to T1 plus T2. I hope you understand the theorem, guys. You can just prove it by yourself, or you can just pause the video and do it by yourself, or just go back and start the video again so that you can clearly understand the theorem. Yes, I hope you understand the theorem, guys. Then the reason you're gonna use for this theorem, obviously, it is tangent chord theorem. You can just say tangent chord. So how do you recognize tangent chord, guys, in an examination? I'll just show you how do you recognize it. There's a symbol Z here. If you have a Z here, this means let me just say this angle here is going to be equal to this angle here, this angle here. With the symbol Z, let's check where is Z here. If and only if this line is a tangent, then this angle is going to be equal to this angle in the alternating segment or in the other side of segment. Then we have a chord here. Let's go back to the diagram. We have chord TB. Then TB, it makes T1 plus T2. Then we have this chord TC. This chord TC, just like here. That means I'm going to form Z with the inclusion of TC time chord. I mean this chord TC. Oh guys, that means we have Z here. You can see that there's Z again in this way. This means this angle, this two angle T1 plus T2 is going to be equal to this angle in the alternating segment, only P2. So in the examination, how do you recognize time chord? By Z shape. Z, meaning the inside is equal to the outside, the tip is equal to the inside, the tip of the angle is equal to the inside of the angle. The tip P2 is our tip, is equal to the inside of the Z, which is T2 plus T1. I hope you understand what is time chord and how do you recognize, how do you recognize tangent chord in an example. I'll just show you at the later stage in a proper examples that are critical. So let us go to example of this theorem and explain it more thoroughly. So here is an example. It says that determine the size of angles marked with letters. In the following equation, MT is a tangent to the circle at point P, and the circle has center O. Center O, tangent at point P. So let us explain tangent chord theorem. Obviously, when I say tangent, you remember tangent chord theorem. Remember theorem 6 that talks about tangent perpendicular to radius. So in this case, we have a center here and a radius of the radius. Here, tangent. So you have radius and tangent here. Obviously, MT is a tangent, but let's focus to PT only here. PT and OP, tangent, radius, 90 degrees. Remember, guys. Remember that. Just remember that. I hope you clearly understand what's happening here. So we're gonna find x and y basically here. Then remember again, radii are equal. I hope you understand, guys. So let us simplify this example thoroughly. So x plus 62 is equals to 90. Then tangent perpendicular to radius. I hope you clearly understand what's happening here. And then you're gonna just transpose that 62 to solve for x. We're gonna just say x is equals to 90 minus 62. Then x is equal to 28. This is the value of x, 28 here. I hope you understand, guys. I hope you clearly understand this question. Then again, there's another problem here, guys. So let us recognize let us check the tangent chord theorem. Where does it apply in this case? Tangent chord theorem. That's Z. Z. Remember Z. Where is Z here? Here's our Z. Tangent chord, tangent, and we take our chord PB. Chord PB, and we have Z. Z is our Z. That means this angle 62 only is equals to our tip angle A beta. I hope you guys understand what's happening here. Yes, this means this angle here is going to be equal to 62. Because of what? Tangent chord theorem. Basically, angle A is equals to 62. Reason tan chord theorem. Why do I need tan angle A? Because I see that y is the center, and y according to theorem number 2, y is equal to 2 times theorem 2 times angle A. So y is equal to 2 times angle A. This means what does it mean? Angle at center is equals to 2 times angle at circumference. Theorem number 2. Therefore, 2 times 62 is like you're gonna just multiply. You can just substitute where you see A, you put in 62, then find for y. Then y is equals to 124. I hope you understand, guys, what's happening. I hope you understand, guys, what's happening here. Therefore, y is equals to 124. I'm done with finding x and y. Alternative way you can use to find y, just simple. Already we have x, which is 28. So let me just write the alternative way to find y in this case. So we have x, which is equal to 28. This means you go to b2 is going to be equal to 28. Now your reason, remember you have two sides that are equal, isosceles triangle, angles opposite equal sides, angles opposite equal sides. Remember, then you go to 28 monana, then you're going to find y by using angles of triangle. Y plus x plus b2 equal to 180. As in interior of triangle. Then y, we want it, x is 28 plus 28 is equal to 180. Then y is equal to 28 plus 28. 28 plus 28 is 56. Then 180 minus 56, it is 124. I hope guys understand what's happening here. So this is the alternative we can use to find y. So let us go to theorem 8b, the converse of this one. This one is not long, 8b. So theorem 8b, the converse, the exact opposite. The converse is the exact opposite of theorem 8a. So this opposite means there's something that was implicated in theorem 8a. Now it's not implicated in your probability. Indeed, it's included. That's basically what it means, a theorem that talks about the converse. So if a line is drawn through the endpoint of a chord, basically we have a line. Here we have an endpoint. Here's our endpoint. They talk about this line, PAT. This line is drawn at the endpoint of a chord. Which chord? Can be this chord or this line. Also, they can talk about which chord? This chord in a bass cap. So if this line made up by a chord drawn through the end of a chord, basically making an angle equal to the alternating segment, then the line is a tangent. Basically, if we have our z, remember our z. So if you have z kind of a thing, let us check here. Where is our z here for this one? If you have this angle being equal to this angle, because of what? Tan chord. Remember our z. If this angle is equal to this angle, and our z also, this angle is equal to this angle, this will mean that this line is a tangent. That's basically what is being said here. If that's the case, then line PT is a tangent. They can say we must prove tangency in that form. So if this angle is equal to this angle, this angle is equal to this angle due to tan chord, then PT is a tangent if and only if these two angles are equal. Angle this one is equal to this angle, then this angle is equal to this angle due to tan chord, then this line is a tangent. The reason you can use for this theorem is angle between a line and a chord, or converse of tan chord theorem, then you're done with this theorem, guys, basically. So don't be surprised when you meet such questions in the examination, but this one is not asked too much, but you need to understand theorem 8a. Yeah, 8a. So sometimes they could say that you must prove go to this angle is equal to this angle, or this angle is equal to this angle in the examination, guys, when you prove in theorem 8a. But usually they always ask you must prove this angle is equal to this angle. There's not much of being asked to prove this angle is equal to this angle, but you need to understand whatever that is being implicated in this theorem so that you can move the examination. Yes, thank you very much. I hope you're gonna enjoy your day, and remember to master circle geometry. All this need right now is practice. So in the next video or in the next lesson, you wanna simplify some few questions that involves circle geometry theorems, and that examinable also in maybe in the trial or in the previous question papers. So I'll just combine some few questions from previous question papers to test you guys basically, so that you can prove indeed you understand circle geometry at a proper level. Thank you very much. Enjoy your day.